Okay, I'm going to basically take this sucker here. This is an alternate configuration. This was the first configuration, but I'm not going to mess with that just right now. So, I'm going to select a manual mesh. Okay, and I don't want to use the previous, because the auto mesh was fine, but I wanted to show you kind of how this worked. We are dealing with a cavity, so I don't know if this is significant or not, but I'm going to set this to auto and then hit mesh. So you can see if that looks refined enough for your purposes. It's a little better than what we got, I think, with the auto mesh. We can reduce the size if we want to, but I'm going to go ahead and try it like this, and leave it that way. This is showing no problems with it, so and that takes us back to here, but we're still not done with it. So there's all this other crap that we can deal with, but we got to define the internal mesh because we're dealing with a solid mesh type. So, and I'll just leave it at default and hit transform down here, and when you do, you'll see it does a split away, which lets you look at the internal version of the mesh. Okay, so I'm going to go ahead and accept that, and then notice at this point that we got an OK. So, and really we can't go anymore, and it's kind of leads you around in circles, but that's what I did. I just kind of hit OK. So we can look at our mesh again if you want, but stop out of it. Now as you go through this, what you want to see is green check marks on everything. Now, I'm not sure if this has it, but on the older version you used to be able to choose a machine type, and you might still be able to here if you actually are doing multiple molds. Maybe that was the trick, but I just noticed that I don't seem to have the machine type and they do. So some of the 2013 2012 versions of this under material, but you want basically all these to have green check marks on them until you get down to your run. So what you do is just kind of go through here, oops, and you can just choose the default ABS. I think I chose this one. It's looking, this one is looking for something with a wide span on it. Okay, now if you see there's a check mark there, we can go into mold, okay, and this has a default steel alloy chosen. So okay, go ahead and click OK, and I'm going to go into help and make sure the fucking units are set right. Okay, but that has a green check mark on it too. So go into fill settings, okay, and that's in degrees Fahrenheit now, and basically I'm just gonna leave automatic there for that, and pack settings, leave automatic there for that, and warp settings, there's no automatic, but I'll go ahead and choose their default. And like I said, we're getting green check marks filled in here progressively here. Mold wall temperature, again, just go apply. I don't think you need to do that, but I've got a green check mark. Runner element, okay. Now we're don't have a runner element here, so choose that, but it still gives us a green check mark. Filled hot runner. Again, hit check. Injection location. Now here, you know, you can have it automatically select by hitting that, and we'll just use one location. So it chose the middle right there, you know, as its place, you know, which may or may not be the best place, but you know, it's a good central location. But you know, these you know, that may be, you know, in other words, we may actually prefer it being like here instead of there, because that might be hard to cut the runner off. So, but I don't know if I can just simply choose it to be there instead. I don't know if that's a second runner or what it is. Okay. I don't want to add, but let's go ahead and delete that location and select it to be right there and say add. Okay, so this will be a little different than what I did before. I don't know if that's going to generate a problem, because the last time I just automatically chose it. I just don't particularly like that location. Okay, 0 to 100% shot. Alright, well, you know, it'll be experimental, but I'll try it there. Okay, warp boundary. Just hit OK on that. Okay, and at that point, you know, we've got all green check marks here. Now we should be able to go do a run. Okay, if you double click it, and then like 90 minutes later, you know, you'll have your results. So I'll get back to you on that. You know, but as it's running through the results, you know, it'll start doing an injection preview here. So, you know, you can extend these results out if you really want to see what's going on. But anyway, we'll see how long it takes. I think this is a coarser mesh than I ran last time, at least slightly coarser, so it might run a little faster. You know, last study I did on this took like 190 megabytes. I don't know if this will be any bigger, you know, for the file size. So it was up there a little bit, but not that bad. But I do have training videos on, you know, some of the other stuff, but again, it just kind of hints at it, and you know, and I haven't really watched them thoroughly yet. But you know, at some point when you're ready, you know, you can start trying to mess with the runners and stuff. You know, and doing multi-cavity or multi-part cavities or molds. But I just still wanted to show you the basics, you know, of how to at least run the studies and what you basically go through to do a study with this. You know, last time I ran a study, I actually just chose the first one because I wasn't even paying attention to what I was doing. So it, you know, this one I ran the warpage and everything else, you know, but the first one just, you know, was the flow. So, you know, this one I'm running all three of those, so it's gonna produce, you know, some additional information, I assume. I do have a lot, several good videos that I found, you know, on YouTube that are actually, you know, they don't involve this per se, but they involve the complete mold design. I mean, on a complex mold too. I mean, with fucking pins in it and everything. So, you know, I've got, you know, on your other computer, you know, I've got videos on your i7 about, you know, copies of those videos. So, you know, they're worth a watch. You know, if it becomes relevant. It looks like it's getting close to wrapping up. Okay, just finished up, and that actually wasn't that bad. That only took like 6 or 7 minutes. Still just finishing up, but doing this warp analysis, I suppose. Now it's pending on the warp, so it still might be a while longer, but anyway, the flow alone took 20 minutes last time. Okay, now it's running the warp analysis, so it took it, say 10 minutes to finish up with this totally. But yeah, I'm looking at this other guy using 2014, and he doesn't have a machine either, so on YouTube. So anyway, okay, yeah, it just took a few minutes, so that was, total time of about 15 minutes or so. So we're running all three of these, which again, the whole thing took at least that long last time just to do a flow. But it's 3600 psi, so that's the pressure. And it's just giving you a report of the material, etc. So, and how many seconds it took, so you can see it took about 3.7 seconds to fill. But again, just like before, we can play it back in these various modes. So, including sectional, etc. Okay. Clipping plane is. Turn that off. Stop on that. Velocity. You can't hit play when you have velocities in there. Change the number of vectors, so look at your weld lines. So, it's saying, showing you where those are going to be. Our air traps. Don't really see any air traps. There's usually some. So I guess that was a good location I chose, huh? So fill time. You look at the pressure, so it shows you where the lowest and highest pressures are. In this case psi. Temperature end of fill time, so it's still hot here. Bulk temperature. Working with temperatures you have for that plastic. Low front central temperature. Temperature growth at end of fill. Shear stress. shear rate, volumetric shrinkage, freeze time at end of fill. .7 seconds. Okay. Cooling time. Total 31 seconds. Now I don't know that it needs to remain in the mold or not. The temperature at the end of the cooling. Show you some sink marks, but we shouldn't have too many of those because we don't have any ribs or anything. Gate filling contribution is 100% since we're using just one gate. Okay. So that's suggesting this is frozen at the end of the fill, but still it does say that this part can be successfully filled with an injection pressure 25 megapascals. So so it will fill. So at any rate, so that's pretty slick. That's flow results. Okay. That's the pack results. So we got actually these 3 tabs. I didn't see that. So we're looking at flow before, but the pack, pressured into packing, temperature into packing, volumetric, residual stress, etc., warping. Let's see. Interesting. So, it gives you a better idea, what the warpage might be like, but again, I don't think it's that severe. So, but at any rate, it shows you that it's really 1.3 or 13.2 mil, is what we're talking about. you know, in the red zone, so, you know, which isn't all that bad really. And again, but I don't know, you know, we're talking a warpage here, it's supposed to shrinkage, but given the fact the warpage is somewhat uniform, X direction, Y direction, and Z direction. Okay. So it's only about 2 mil in that direction. So X direction is about 10 mil. Z direction is 8 mil, I guess. So anyway, pretty interesting. XY plot. Cool. Summary report. You can export it, you know, because you can't export it to, you know, to like the simulation package. So I think that pretty much kind of, you know, gives you an overview of the whole thing. So like I said, the first time I just ran like, I don't know, one of these, and I think just the flow is all I ran, but and we ran all three of them here. So anyway, pretty much covers the basics of how it works and what it does. So fundamentally, but again, there's a lot more to it because you can do multi-load layouts, do runner balancing, etc. So there's a lot more functionality than what you see here. It's just the basics.